Okay, we're back. Going to talk about example 4.2, 50 newtons, negative y direction, 2-meter lever arm, 60 newtons, positive x direction, 4 meters in the x direction, 0 meters in the y or z. 20 newtons at 3 meters times the sine of 30 in the negative y for the R component, for the lever arm component, 20 newtons in the positive x for the force, and then the 40 newtons. 40 newtons negative y direction, and then it's at a position of 4 plus 3 times the cosine of 30, that position right there. So it's negative 50 times 2 meters, that's the lever arm, 50, tending to move it clockwise, so it's a negative. 60, 0, it's aligned along the x-axis. The line of force of the 60 newtons intersects with the O, the moment we're calculating the point we're calculating the moment about, and so that would give you 0 newtons. The 20 newtons, positive x, 3 meters, sine of 30. And it tends in the counterclockwise direction, so it's positive. And finally, the 40 newtons, negative y direction, and it has a positive x lever arm. And when you do all the calculations, you get 334 newton meters tending clockwise. Negatives for the tending clockwise. Positives for the tending counterclockwise. Okay, let's look at the Excel spreadsheet. So here is the lever arm. Oops, come on, you silly machine. There it is. Lever arm. 2 in the x direction, negative 50 in the y, negative 100, so that's tending clockwise. Just like before. Right here. No forces in the z at all, by the way. I'll show you the formulas for the Excel spreadsheet in just a second. So R60, it's 4 meters along the x-axis and 60 newtons along the x-axis. The force and the axis are parallel to each other, so you expect a 0 moment. So here's the magnitudes, by the way, the column with all the magnitudes. The R here, so let's go down to this force right here. R will be the same, that you're going to have 4 plus 3 cosine 30 for the x coordinate and 3 sine 30, negative 3 sine 30 for the y coordinate. In both cases, only these two cells make a difference. And since they are tending counterclockwise, they should be positive. They're tending to rotate the system counterclockwise. And that's what you get when you run the formulas for the cross product. They're coming up a little later in the chapter. I'll show you those. Okay, so the distance is the same for both. R40 is in the negative 40 newtons, negative y direction, and the formula runs through this. So we get negative 333.9. They rounded it to negative 334. Okay, that's it. Let me show you the formulas in this Excel spreadsheet. Now, a lot of these had errors in them right here when we talked about formulas, because you had a 0 And let me also format this auto fit column width. Okay, so it's nice and pretty. So here is the formula for the x-axis moment is this cell times this cell minus this cell times this cell. Y-axis moment would be this cell times this cell minus this cell times this cell. The z-axis component is this times this minus this times this. Magnitude. You take the square root of the sum of the squares, and I went a little too fast. There we go. Magnitude. Square root of the sum of the squares. All of the above. Unit vector. You take the components, so the x-axis component is in B2, cell B2. There it is, B2. And the magnitude's in E2. And the magnitude for the next vector is in E3. The magnitude of the next is in E4, and so far. Keep going, keep going, keep going. This is a divide by zero error. Remember, the magnitude of the moment is 0 in this case. So here you're dividing by 0. So all these green things say they're telling us you're dividing by 0. We can't calculate it, which is an error you expect. Okay. And then the angles. We just take the unit vector and find the arc cosine. And everything in Excel is in radians. So you get a number, you get a radians here, you got to convert it to degrees. 180 divided by pi will give you degrees. So it gives you the angle cosines. Or excuse me, the angles. The unit vector is the angle cosine. Okay. The components of the unit vector. And of course, y and z are very similar. Now for the last, so these three, all the vectors, we're just setting up r cross f, and so forth to get the moment, to get each moment. Here we're just taking the sum, sum, and then the rest of them, square root of the sum of the squares, and finding the unit vectors, and then finding the angles, just like the previous rows. Okay, so it's an Excel spreadsheet that's all set up so that I can go back to it. I can use it whenever I need to. Let's go to this one, three-dimensional problem. So we have a force, and we've got to calculate UAB. So you find out R, determine the moment produced by F, about point O, express the result as a Cartesian vector. It's three-dimensional. So you have a lever arm, which is from O to A, which is 12 meters I hat, or excuse me, 12 meters K hat, Z-axis. And then express force in terms of its XYZ components. So for that, we'll need UAB. So I'll go to my Excel spreadsheet and show you guys in just a second. Pause the video. Okay, let's take a look at this Excel spreadsheet. ROA, given by this. ROB, given by this. And then the vector from A to B will be given by this. And it's identical to what the book says. This will calculate the unit vector. Now here we have a formula. The unit vector, the x component of the unit vector times the 2 kilonewton force gives us the vector force along the cable. This is the unit vector along that cable from A to B. So we get the force along that cable. And then this is, I already showed you the formulas for this calculation. Negative 16.5, positive 5.5, 0 z-axis moment. Let's go back to the board. So the forces are all the same. You can compare them to my Excel spreadsheet. And what did I say? Negative 16.5, negative 5.5. 5.51? Yeah, 5.51. Or positive 5.51. There it is. Negative 16.5 in the x direction, 5.51 in the y. Same as this. And of course, units. Kilonewtons times meters. Everything's in meters, everything's in kilonewtons. Okay, gonna end this video here, go to the next video.